Yes, sir.
So today we are going to study about equilibrium chapter. There are two chapters in equilibrium. The first one is basically chemical equilibrium. So what it is about chemical equilibrium, what is chemical equilibrium? We will just start, okay? Only two students came till now. Okay, let's start. What is chemical equilibrium? Basically, I'm going to define it and then I will explain it. Write with me, please. It is defined as point in reversible reaction. Already you know what is a reversible reaction, because in thermodynamics we studied two type of process, that is reversible and irreversible too, right?
Yes, sir.
At which the rate of forward reaction is equal to rate of backward reaction. As you know that a I'm writing like a reaction like this, you can say that this is a reversible reaction. Reversible reaction says that a is converting into b and b can also be converted into a. Is that clear, Ifra and Krishna?
Yes, sir.
Yes, sir.
Now see that a is converting into b and b is converting into b can convert into a. And what is chemical equilibrium? When a rate of forward reaction, that means rate of rate of formation of product from a to b is equal to rate of formation of b from a. Sorry, rate of formation of a from b. That means when a is converting into b as well as b is converting into a at the same rate, the rate should be same. That point is called equilibrium. Is that clear?
Yes, sir.
So here is a note about this. The chemical, this equilibrium is basically dynamic in nature, and you studied in physics static and dynamic. Static means at rest and dynamic means that is in motion. So you can say that I already wrote it, that rate of forward reaction, that it means it is moving from left to right as well as right to left. That's why it is dynamic in nature. So I'm going to write it is dynamic equilibrium. It is dynamic equilibrium because reaction proceed with same rate in both direction. Basically this is in motion, that's why it is dynamic in nature. And when we will say it equilibrium, when rate of forward is equal to rate of backward. Simple. Just write it and let me know, Krishna.
Done, sir.
Ifra.
Yes, sir, done.
Okay, I'm going for the point number 3. It's all about equilibrium. Just the first point is rate of forward should be equal to rate of backward. That is the point where equilibrium exists. Now in terms of concentration, we are going to talk about equilibrium. Concentration of reactants and products. Concentration of reactants and products do not change with time. If concentration is not changing, that means it is constant, right?
Yes,
Yes,
sir.
So it's not necessary that concentration of reactant and product should be equal. Necessity is that it should be constant. It shouldn't be changed. The concentration of reactant as well as product. Fourth point about equilibrium is that mole, either mole, mass, or intensity, or we can say that color of reactant, intensity of color of reactant and products do not change with time. Do not change with time after attaining equilibrium. After attaining equilibrium. At equilibrium, this moles, mass, intensity of color of reactants as well as product, these do not change. They can be equal, but they must be constant. Their value should not be changed. Is that clear?
Yes, sir.
yes, sir.
So we are going to have 3 graphs on rate of reaction with time and 3 graphs on concentration versus time. Rate of reaction versus time and concentration versus time. So you are going to pick up which one is correct and which one is wrong. First, we will talk about rate versus time. First, write it and let me know.
Done, sir.
Done, sir.
Okay, thank you so much. So moving to the next point. Rate versus time graph. Rate versus time graph. Now you will see that there is a graph. 3 graphs I'm going to give you. Let me know which one is correct and which one is wrong. So just tell me first, this is between rate versus time. If I'm going to draw 2 lines on this graph. First one is from here and second one is from here. Let me know which color represents which, reactant and product. I'm talking about which line is for reactant and which curve is for product.
Sir, red one is for reactant and the blue one is for product.
Ifra?
Yes, sir. Same.
Same. Just let me know if you're going for the blue one or whatever color is this. If you are saying that it is product at initial, just see at initially t equals to 0, what is the concentration or number of moles and whatever it is, concentration of reactant and concentration of product? What can you say that when reaction doesn't start or it is about to start, concentration of product should be 0 or not?
Yes, sir.
Yes, sir.
Krishna? And
Yes.
what about reactant? When we will have some reactant and then it will react to form product, right? That means reactant
Yes.
is not equals to 0. It has some value. That means just see, here is time 0 as well as rate is also 0, right? Because time is 0, so that means this is for a reactant and this is for product. Okay, is that clear,
Okay, sir.
Krishna?
Sir, can you
Yes,
explain?
sir.
Yes, yes. Just see, if I'm telling you that this A is converting into B, A is converting into B.
Yes, sir.
So at t equals to 0, that means it is about to start. That means let's say it has concentration C, because reactant must have some concentration to react and form product.
Yes, sir.
And at t equals to 0, what will be the value of product? That is 0, right?
Yes, sir.
And on the graph you can see here is the rate of this will be the rate of forward, because this no, rate of forward reaction is because of this concentration,
Yes, sir.
because it has some concentration to react and form B. And what about B? B will start from 0 na, and B is what? Product. B is product na.
Yes, sir.
So B will start from here. That's why we will call it RB, that is rate of backward reaction. Is that clear?
Yes, sir.
Yes.
Okay. So basically when it starts from 0, that means it is for product. And product, now what is product? Product is basically rate of backward. The product is for rate of backward, and reactant is for rate of forward. Okay. So this is the graph for first graph, and I'm going to take another graph, rate versus time. Let me know which one is correct. This is rate of forward and this is rate of backward. I'm going to take another example, another graph. This is for time and this is rate versus time. And you can see I'm going to plot a graph between this like this and like this. This is rate of forward and this is rate of backward. Tell me which graph is correct, correctly represents equilibrium. Why are you late, Fawaz? Saif?
Second graph.
Second graph. You are talking about second graph. Very good.
Sir, sorry, means like I was talking about third graph. I think third graph.
Third graph is correct. You're saying that third graph is correct. Any answer from Krishna?
Yes, I think it's second graph, sir.
Second graph. Very good. Then wait for some time. Saif, am I audible to you? Fawaz?
Yes, sir.
Yes, sir.
Okay. First, just write. I'm going to explain it. Don't be late, please.
सर लेट नहीं, वो निष्कर्ष सर ने पता नहीं कौन सी लिंक भेज दी थी.
Okay, so you always start with the answer, send the link. Just save the link for the next class. Okay.
Okay.
7574145800. Okay.
Okay.
Password 151214.
हाँ, ये सेम होता है ना हर बार.
Yes. You can see what is chemical equilibrium. Chemical equilibrium is a point in a chemical reaction or in a process where rate of forward is equal to rate of backward. It is for only reversible reaction. And as I already told you in thermodynamics, what is reversible and what is irreversible. Reversible is that when A will be converting into B and B can also be converted into A. That is reversible process. In this process, when rate of forward reaction, that means rate of converting from A to B, and rate of backward reaction, that means rate of converting A from B. That means A is converting into B and B is converting into A at the same rate. The rate should be equal. That point is called reversible, chemical equilibrium. Is that clear, Saif? Fawaz?
Yes, sir.
Now,
Yes, sir.
coming to the next point, very good. This equilibrium is basically dynamic in nature. In physics, you have two terms. You already know that. Static and dynamic. Static says that at rest, and dynamic, that means in motion. So basically at equilibrium, rate of forward is equal to rate of backward. That means this is A is converting into B, that means it is in motion, as well as B is converting into A at the same rate, B is also in motion. So due to this motion, this is called dynamic equilibrium. Is that clear?
Yes, sir.
Okay, write it or take a screenshot. Okay,
Okay, done, sir.
done. Now see, concentration of reactant, it is all about equilibrium. Rate should be equal. Rate should be equal. Rate of forward as well as rate of backward should be equal. Now coming to the point, concentration of reactant and products. Concentration of reactant and product at equilibrium should be constant. It doesn't change. It should be constant. If concentration of reactant and product is constant at any time, that represents it is at equilibrium. Is that clear?
सर फिर से बताएंगे फिर से?
That means I am telling you that A is converting into B. Okay, the concentrate after some time, A first this is reactant and converting into B. After some time, the concentration of A or B, just suppose it was initially 10, after some time it is 3 and it is same, it is 7, it is 7 and it is 3. Now at this time, and you will see there is no change with time. That means concentration of A and concentration of B is now constant. This time represents equilibrium. Is that clear, Saif? It does, this value does not change with time.
Okay, sir. Okay.
Yes, sir.
Now talking about concentration, concentration represents what? Moles per liter. So in terms of mole, mass, intensity of color of reactants as well as products should not change with time. It is the same point as the previous one, that this should not be changed. It should be constant. This point represents equilibrium. Is that clear?
Okay, sir. Yes, sir.
Yes, sir.
Okay, take a screenshot. I'm going to slide it down.
Done, sir.
Okay, thank you. Now I'm going to give you a graph, rate versus time, rate versus time. Okay, rate versus time, and you need to choose which one of the following is correct. Which one of the following is correct? So here is the answer from Ifra and Krishna. Krishna said that this one is correct, and Ifra said that this one is correct. But the fact is that only this one is correct. Am I audible to all of you, Krishna, Ifra?
Yes, sir.
Now see, I'm going to explain it, Saif. In terms of rate, the first point, what I was written, the first point says that rate of reaction, rate of forward as well as rate of backward should be equal. It was written or not?
Yes, sir.
Yes, sir.
Now you will see that in this graph, if you are going for rate of forward, this value is different from rate of backward.
Yes, sir.
That means it is not equilibrium. It is not in equilibrium, right?
Yes, sir.
Yes.
Now if you will go for the third graph, you will see this is rate of basically backward, this is rate of backward, and rate of backward has different value from rate of forward. That means it is also not for equilibrium. This graph is possible, but it is not equilibrium. Is that clear? Ifra?
Yes, sir.
Now
Yes,
if
sir.
you will go for this, you will see that rate of forward after some time, here you will see that they are overlapping, they are coincident with each other. That means they have same value. Rate of forward is equal to rate of backward, Krishna.
Yes, sir.
So this is correct.
Yes, sir. It's correct.
So I just gave you the graph between rate versus time, and I will give you after this the graph between concentration versus time. So for equilibrium, there is no equilibrium in this. At some point, at this point only, there is equilibrium at this point only. But the graph is going away from this, that means it is not in equilibrium. But at this point you will see there is no change in rate of reaction, rate of forward as well as rate of backward, that this represent after this is in equilibrium. Please write it and let me know.
Done, sir.
Very good. If everyone done, let me know, please.
Done, sir.
Very
Just a minute.
okay, no problem. Take your time.
So second graph is not possible.
Yes, not for equilibrium. It is not for equilibrium. There is no equilibrium in this graph.
Okay, sir.
There is only at one point, this point, where rate of forward is equal to rate of backward. Go for concept and then try your concept in the question.
Done, sir.
Seth, are you getting it? Why were you late? Do you also have different link?
No, it's just overslept. I was just sleeping.
Okay. Let me know if you are done with this. Are you done with this?
No, 1 minute, sir.
Okay, take your time, no problem.
Yes, sir, done.
Very good. Now going for the second graph, concentration versus time. For concentration versus time, A is, there will be three graph like the earlier. You just need to read or understand graph. This x-axis represents time and this y-axis represents concentration. Tell me, Fawaz and Saif, the yellow or the pink one, which one is for the reactant and which one is for product?
सर रेड वाला प्रोडक्ट है
Okay.
और येलो वाला रिएक्टेंट.
Okay. Thank you. You are checking it for which one has which represents equilibrium.
Sir, second. Sir, second is correct for concentration and time.
Very good.
So may I tell the reason?
Yes, yes.
So because the concentration of reactants and products do not change with time and they are constant, so they will not attain equilibrium. But in other two graphs, they are attaining equilibrium at some point. That's
So
why.
we need to tell which graph represents equilibrium. Which graph represents equilibrium? So this one is correct according to Ifra. Anyone? Any answer? Krishna? Krishna, your voice isn't coming. Fawad, Saif,
Sir, I'm thinking it's C, sir. The
C.
I mean,
You are going for C. Okay. Very good. Fawaz? Fawaz?
Sir, C वाला, C वाला.
C. What about you, Saif? Okay, I'm going to explain it. The correct answer is
sir, it's
A,
A, sir.
B, and C. The correct answer is A, B, C. All have equilibrium. Now go for the concept. What I told you is that the concentration of reactant and product should not change with time. That means with time, the value should be constant, right? Everyone?
Yes, sir.
Now, if you are going to check after some time, the concentration of a reactant for yellow as well as the pink one is constant, as well as in this case they are equal. In this case they are equal, but with the time they are overlapping with each other. That means this value are constant or not.
Yes, sir.
That means this these attain equilibrium. Krishna?
Yes, sir.
Now again the same sentence I am going to repeat. The concentration of reactant and product should be equal. The concentration of reactant and product do not change with time. If you will see that after some time this will be constant or not, reactant and product.
Yes, sir.
It will go a straight line, no? And if you will, it will go a straight line, the concentration will not change. Are you getting my point, Saif, Krishna?
Yes, sir.
So this is also true. Now come to this. After some time, if you will say this is going a straight line, that means time is changing, but the concentration of product is not changing, as well as the concentration of reactant is also not changing with time. That means it is constant. So it is also true for equilibrium. Am I correct?
Yes.
So can you explain the graph of second and third again?
Second and third again. What is the criteria for concentration for equilibrium? Concentration of reactant and product should not change with time. Should not change with time. That means concentration of reactant and product should be constant. Is that correct, Saf? Please unmute and talk to me.
Yes, sir.
Now if you will see, after some time this graph is going straight parallel to the x-axis, both the reactant one on the product one. This is for reactant, this is for product, this is for reactant, this is for product, because product will start from 0. Okay. Then after some time you will see that the concentration of reactant is constant, as well as concentration of product is also constant or not.
Yes.
And if they are constant, that represents it is in equilibrium. Again,
Yes, sir.
that represents this is the condition for equilibrium, and it is satisfying it that with time concentration doesn't change. Now if you will go for this, after some time it is going parallel to the x-axis. So if you will find the value, if you are going to find the value of reactant, this is for product and this is for reactant, because reactant coming to downwards, so it is also constant, the concentration of reactant as well as product. So if it is constant, that means it is satisfying the condition of equilibrium. Is that okay?
Yes.
Okay, thank you. Just write it. And if you have any other doubt in this, anyone, ask me, please.
Sir, all are correct, right?
All are correct. All are in equilibrium, we can say. This is condition for equilibrium. All are in equilibrium. Done. Very good, Ifra. If you are done, everyone, let me know, please.
Yes, done, sir.
Done, sir.
Done. Thank you. So going for law of mass action. Law of mass action. First write it with me and then I will explain and you will see. According to this law, according to this law, the rate of reaction is directly proportional to rate of reaction is directly proportional to molar concentration of each reacting species, molar concentration of each reacting species with raised to power which must be equal to its stoichiometric coefficient, which must be equal to its stoichiometric coefficient of reactant. This is law of mass action. Just write it and then I will tell you what it is exactly.
Done, sir.
Done, everyone?
Yes, sir.
Yes, sir.
Now I'm Saif.
Yes, sir. Done.
Okay, thank you. So I'm going to take an example, very easy. A plus B is going into C plus D, converting into C plus D. That means you can say that A and B is reactant and C and D is product. If I am going for a rate of forward reaction, rate of forward direction according to this law is directly proportional to the rate of forward. Rate of forward is directly proportional to the concentration of it, concentration of reactant to the power its stoichiometric coefficient. If I'm what is its stoichiometric coefficient? A. For A, what is the stoichiometric coefficient?
1.
1.
And for B it is 1. So
One.
I'm not you can write x raised to the power 1, or you can write x. Both are equal. Both are equal or not?
Yes, sir.
Yes, sir.
Yes, sir.
Now this is for rate of RF, that is directly proportional to A into B. And now a rate of forward will be equal to KF into A into B. For removing this proportionality sign, we have a constant. This is forward rate constant. Forward rate constant. This is for forward. Now going for backward. Rate of backward is directly proportional to this one, C and D. As you know that when we are talking about rate of backward, that means C and D is converting into A or B. Is that clear? Rate of backward means C and D combined to give A plus B.
Yes, sir.
So in the same way, rate of backward will be directly proportional to the concentration of C into concentration of D, and here stoichiometric coefficient is 1. That's why I don't need to write 1 and 1. That will be equal. And for removing this proportionality sign, I am writing it KB C into D. This derivation is not important for you, but you need to understand how the formula comes. That will be much important. Okay. So there is rate of and you can see this this RB is backward rate constant. Backward rate constant. Is that clear, everyone?
Yes, sir.
Ifra, Fawaz, Saif.
Yes, sir.
Yes, sir.
Now you know that at equilibrium, in terms of rate, at equilibrium, rate of forward should be equal to rate of backward. Do you remember this from the graph? Rate of forward should be equal to rate of backward. Is this
Yes.
clear or
Yes,
not?
sir.
No. Very good. So I'm going to put this value like KF into A B will be equal to KB C and D. Again, I'm going to just solve it, and it is so easy to understand that KF upon KB is equal to C D upon A B. What I just did is I just take KB from here to in it denominator of KF, and then AB to the denominator of CD, and this is important. This KF, forward rate constant upon backward rate constant, is known as equilibrium constant. It is known as equilibrium constant. So if there is any question, what is equilibrium constant, and if you have given options like KF upon KB, KB upon KF, KF into KB, and whatever it is, just remember that equilibrium constant is equal to rate of forward reaction, forward rate constant upon backward rate constant. So we have a formula for equilibrium constant, that is, for equilibrium constant, this is very important. For equilibrium constant, we have a formula, that is, first of all, you are going to write the product side in numerator and the reactant side in denominator. So C, concentration of C into D, concentration of A into B. This is the formula for equilibrium constant. So please write it, and if you have any doubt in this, let me know. This is just a derivation. If you are done, then let me know.
Sir, here A and B are molar concentration, right? A and B and C and D.
Yes, the square bracket, basically the square bracket represent concentration, basically molarity of everything. Either it is A, either it is B, C, D, it's all a square bracket represents molarity.
Okay, sir. Done, sir.
Done, everyone? Fawaz?
Yes, sir. Done.
Yes, sir.
Okay. Saif?
Yes, sir.
Okay, just write it then.
Done, sir.
Done, everyone?
Yes, sir. Done.
Yes,
Very
sir.
good. So this is basically, if I'm going to give you another example, just see. If we have a reaction like A plus BB will give CC plus DD, and you need to write K equilibrium. That's I'm saying it KC. Just write K equilibrium as KC, and after 15 minutes you will know what is KC basically. So here, first of all, you are going to write the product side on the numerator and the reactant side on denominator. So product side, this is C, and what is its stoichiometric coefficient? C. So I'm going to take it as power. Whatever is the stoichiometric coefficient, you will take it as power. It's power D raised to the power D, and then again A raised to the power A and B raised to the power B. This is the way we write K equilibrium. You just write K equilibrium right now, then I'll let you know what is KC and KP. Is this clear? How I just wrote K equilibrium for this reaction?
Yes, sir.
First write the reactant product side in numerator, and then in denominator the reactant side. Okay, and again write it with power, and power is equal to a stoichiometric coefficient. If there is a power, a stoichiometric coefficient 1, you don't need to write it. You can or you may not. Okay.
Done, sir.
Very good. So now I'm going to write types of equilibrium constant. Types of equilibrium constant. That what I'm talking about is K equilibrium. And K equilibrium here is of two types. One is Kc and another is Kp. And what it is exactly, I will let you know. Just I'm first writing the definition of it, and you'll get it, and then I will explain. If you won't get it, write with me. If concentration of each if concentration of each reactant and product are expressed in Mole per liter, that means molarity, is talking about molarity. Mole per liter, that means molarity. Then equilibrium constant is called Kc. Again, what is Kp? If concentration of reactant and product are expressed in terms of pressure, in terms of partial pressure, it will be a better term. In terms of partial pressure, then equilibrium constant is called Kp.
Done, sir.
Done, everyone?
Yes, sir.
Saif,
1 minute, sir.
Saif, are you done?
Yes, sir.
Very good.
So
So this
Kc is for molarity.
Kc is for molarity and Kp is for partial pressure.
Okay, sir.
Is that clear, everyone? This is
Yes.
so easy to understand. Is that clear?
Yes, sir.
So I'm going to write Kc and Kp for both of the situation. Here it is PCl5 in gaseous state will give PCl3 in gaseous state plus Cl2 in gaseous state. First I'm going to write Kc and then Kp. So for Kc, whatever it is, Kc, either Kc or Kp, the concept will not be changed. First we are going to write the product side in numerator, so PCl3, and here you can see one as a stoichiometric coefficient, and here also you can see as one as a stoichiometric coefficient. So it will be like this, and then again on the product side it will be like this, because here it is a stoichiometric coefficient 1, that means power is 1. Now in terms of Kp, how you are going to write, the concept is same. The first you are going to write product side in numerator like this, P for pressure, and you are going to write PCl3, that represents partial pressure of PCl3 into partial pressure of Cl2 upon partial pressure of PCl5. Is that clear, everyone?
Yes, sir.
Can you repeat for partial pressure?
Partial pressure. Basically, this is pressure, right? For SAF.
Yes, sir.
If this is just a symbol, if you are going to write PA, that means partial pressure of A. So here is three terms. One is in reactant and two is in product. So if I'm going to write P in subscript PCl3, that represents partial pressure of PCl3, and Cl2 in subscript, that represents partial pressure of Cl2. Instead of writing a square bracket, in the same way, if you are writing a square bracket and PCl3, that represents molarity of PCl3, this represents molarity of Cl2, this represents molarity of PCl5. In the same way, we are going to write partial pressure of PCl3, partial pressure of Cl2, partial pressure of PCl5. This P represents pressure, and in subscript, that represents partial pressure, that is talking about the pressure of PCl3. Saf?
So the big P is for partial pressure.
Yes, then yes, partial pressure, and this represents of PCl3. PCl3.
Yes, sir. Thank you.
Okay, done.
Oh, no, 1 minute. Yes, sir. Done.
So the type of brackets are also necessary.
Mm. Basically, this is a symbol bracket. A square bracket represents uh, molarity, and this is always in like a small bracket, so we just took it as. And if you
Okay.
want to take it as a square bracket in pressure, it will be okay, not mistake. Okay,
Okay, sir.
this P will represent all things. Okay, going to write going for another reaction. This is all in gaseous state. This is all in gaseous state, and in this chapter, the physical state is very important. The physical state is very important. After sometimes you will get to know how it is, why it is important. So I am going to write Kp as well as Kc. So you will see Kc is generally students for students they think Kc is easier, but both are equal, both are easier. You can see this is in product, so I'm going to write the product one first. So it will be like NH3. Now you will see that what is the coefficient, the stoichiometric coefficient 2, so it will be a square upon now N2 and then H2. N2, for N2, what is the stoichiometric coefficient? 1. So you just don't need to write 1, or you can write. And what is the stoichiometric coefficient of H2? This is 3. So this will be the Kc for this. Is this clear, everyone?
Yes,
Yes,
sir.
There is no problem in it. Okay, come to this. Kp. P, first write P, and in subscript, you are going to write NH3. That represents partial pressure of NH3. And if there is any stoichiometric coefficient greater than 2, greater than 1, you have to square it, you have to give the power. Now partial pressure of N2, that has a stoichiometric coefficient 1, again partial pressure of H2, that has power 3. Is this clear, Saf?
Yes, sir.
Very good, very good. So if you are done with this, let me know. I'm going to give you a very beautiful question. CaCO3 in solid state, you are going to heat it, and it will be converted into solid as well as CO2 gas. And you are going to find out Kc as well as Kp.
Sir, it doesn't depend like if it is solid or gas, right, sir? It is
It
the same.
will. It will. You done with this? Are you done with this, Krishna?
Yes. Yes, sir.
Yes.
Everyone, Saif, Ifra, and
Yes,
Fawaz.
Sir,
sir.
sir, 1 minute.
Okay, 1 minute. 1 minute is quite lengthy time. Fawaz, we have
नहीं नहीं
only
इतना नहीं, less than 1 minute.
less than 1 minute. Now you don't say 1 second.
नहीं नहीं उतना कम नहीं.
Okay. If you are done with this, let me know.
Done, sir.
Done. Okay. So what I was saying, what I was about to say is that whenever there is pure liquid or pure solid, or you can say solid or liquid, this has active mass that is equal to 1. So we don't need to write the solid or liquid in Kc or Kp as well. If I'm going to write Kc, I will just look for aqueous as well as gaseous state, not for liquid and solid state. Is that clear, everyone?
Okay,
Sir, can you
sir.
repeat?
Okay, okay. I'm going to write Kc. Just see. CO2 like this. What was the concept? And CaO, I will repeat it, Krishna. Just wait. CaO and then CaCO3. Okay.
Yes, sir.
So I told you that the active mass of pure solid as well as pure liquid is 1. This has a value 1. This has a value 1. So what will be left is Kc is equal to CO2. Is this clear, Krishna?
Yes, sir.
Saif,
Yes, sir.
Ifra, Fawaz.
Yes,
Yes,
sir.
sir.
So just remember, you just don't need to write this part. If you will write this part, the examiner may cancel it or just take it wrong. So just keep Kc as this. And if you are going for Kp, are you getting my point? Are you okay with this, Krishna?
Yes, sir.
Saif?
Yes, sir.
Okay, Fawaz, Ifra. Okay. Now, what is the value of Kp? Kp is P is for pressure, and which can be pressure is only for gaseous state, which is what it is for gaseous. You can write Kc for aqueous as well, but you cannot write Kp for aqueous. Are you getting my point?
Yes, sir.
So Kp is basically P of CO2. Here it will be P of CO2 only, like the previous one. What I told you is about aqueous, that I am going to take an example to explain it again. Are you okay with this, Saif? About
Yes, sir.
aqueous? Okay. Come to this. Come to this part, which is very important. So here it is. Here is a reaction. You will see that CH3 COO C2H5 aqueous plus H2O in liquid will give CH3 COOH aqueous and C2H5OH in aqueous. And if you are going to write Kc, okay, first write product side. So you will see the physical state first, the phase first. You are going to see if it is liquid or solid, then just leave it, don't write it. And if it is aqueous or gaseous state, you have to write it. So it is in aqueous state, so I am going to write it CH3 COOH into C2H5OH upon, in the left hand side, this is reactant and this is liquid, so you are going to leave it. And now this is aqueous, so I'm going to write it CH3 COO C2H5. Okay. Now coming for Kp, is this clear for Kc?
Yes, sir.
Everyone, thank you. Saif.
Yes, sir.
Okay. Now going for Kp. Kp here is not defined. Not defined. Why? Pressure is for gaseous state only, not for aqueous, not for solid, not for liquid. It is only for gaseous state. So Kp is not defined for this. Is that clear?
Yes, sir.
Yes, sir.
Okay, thank you. So you are going to write it. I'm going to slide it up. Just write it and let me know. Done, Ifra? Okay. What you just
सर वो PCL5
okay, there is no PCL5 in the previous question, right?
हाँ हाँ हाँ,
Okay, just write it and let me know so that I can will.
डन सर
Done, everyone?
Yes, sir. Done.
Done,
Okay.
sir.
Okay,
Yes.
thank you. Okay. So what you were saying is that now just write it and let me know.
We should keep it in this state only. There's no further calculation over it.
Where? In KC?
No, in both.
In both. If there is some value, this is just a representation. If you will have given the value of this molarity and you will put it and then you will calculate it. Okay.
Yes, sir.
डन सर
Okay. Everyone?
Yes, sir. Done.
Okay. Thank you. What it was Fawaz, PCL5, what you were talking about this?
हाँ वो केसी में PCL5 कैसे PPCL5 होना चाहिए हाँ हाँ
PPCL5 it is. Why there is a problem? P is for pressure and PCL5 represent partial pressure of PCL5.
वो केसी में
KC, this is PCL5, not PPCL5. This is PCL5 na, directly. This represents a concentration of PCL5. We just
हाँ हाँ
keep in denominator the reactant in denominator. Okay.
ओके ओके सर
Okay. Thank you. So, is this clear, everyone?
Yes,
Now
sir.
I'm going to give you a question to write the value of Kp as well as Kc. Fe plus aqueous solution 3OH minus in aqueous solution will give FeOH whole thrice in solid. If you are done with this, let me know.
Done, sir.
Done, sir.
Done. So just make it clear. Kc equals to, this is in solid, so I am going to take it 1. Okay, now Fe plus 3 and OH minus to the power 3, and Kp is not defined, right?
Yes, sir.
What about Kp? Kp is not defined because it is in solid, aqueous and aqueous solution. Is that clear, Saf?
Yes, sir.
Okay, thank you. Going to give you a question which you were talking about, Saf. Is it? So the question is, I'm going to slide it down slightly or completely. The following concentrations were obtained for the formation of NH3 from N2 and H2 at equilibrium at 500 Kelvin. N2 equals to 1.5 into 10 raised to the power minus 2 m. H2 equals to 3 into 10 raised to the power minus 2 m. And NH3 equals to 1.2 into 10 raised to the power minus 2 m. Calculate equilibrium concentration, equilibrium constant, sorry. So you need to find, if it is molarity given, that means you are going to find Kc. And let me know if you can write the reaction of N2 plus H2 will give NH3. Can you write it? Saif, Krishna, Ifra?
Yes, sir.
Yes, sir.
Okay, write it, please. Just few minutes. हो गया? Are you done, Krishna, Ifra, Saif?
Just a minute, sir.
1 minute, sir.
Okay, take your time. It's so easy. The value is basically your answer is wrong. Krishna. Any other answer? Your answer is wrong too. Ifra. So what is the equation reaction you have written?
Sir, NH3 is gas. Right?
All are in gaseous state. Let me know the reaction. On the reactant side, what you have written. First, wait a minute, Ifra. Tell me the reaction. Krishna, what reaction you have written?
Sir, N2 plus 3H2
Will
gives
give.
2NH3.
Will give. Tell me.
2NH3.
2NH3. The reaction is very good. Are you do you have the same reaction, Saif?
Yes, sir.
Okay.
I
What
see the
about
mistake.
you?
I see.
Okay, Ifra, are you with this reaction?
Yes, sir.
Okay. Let me write the expression for Kc. So the expressions for Kc will be NH3 raised to the power 2, then N2, and then here it will be H2 raised to the power 3. Now, just you need to put the value. What is the value of NH3? So NH3 has a value this 1.2 into 10 raised to the power minus 2 raised to the power 2 upon what is the value of N2? It is 1.5 into 10 raised to the power minus 2. Again, what is the value of H2? It is 3 into 10 raised to the power minus 2 raised to the power 3. Right, Krishna, Ifra, Saif? Again, I
Yes,
am
sir.
going to solve it. 1.2 into 10, 1.2 into 1 square of 1.2, that will be equal to 1.44 into 10 raised to the power. This square is going to be minus 4 upon 1.5 into 10 raised to the power minus 2. And if you are going to take a cube of 3, that will be 27 into 10 raised to the power minus 6. Right, everyone? Then here 1.44 into 10 raised to the power minus 4 upon 1.5 into 10 into 27 into 10 raised to the power minus 8. If it will go up, you will see that 1.44 into, it will be in positive and the value will become 10 raised to the power 4 upon 1.5 into 10 27 something. And if you will solve it, you will get 1.06 into 10 raised to the power 3. Is that clear, Krishna?
Yes, sir.
Ifra, you also didn't get any answer. Your voice is cracking. If you're done with this, let me know.
Sir, how 1.44 by 1.5 into 27 is 1.06? It's 0.035, right?
Okay. Yeah, if you are going to solve it, and just see, I'm going to check it out also. It is 1.44, and if you are going to multiply 1.5 into 27, that will be around 1.5 into 27, that will be around 40.5, right? And here it is 10 raised to the
Yes,
power
sir.
4. Okay. And if we will divide 1.44 divided by 40.5, it will be, okay, there is a slightly mistake maybe. Wait a minute, N2 plus 3H2, there is only one. 40.5. Wait a minute, 1.5 into 27. 3 3s are 9, 9 3s are 27. It will be 40.5. Okay. Let me check it. Square of 1.2, it will be 1.44, na?
Yes, sir.
Okay, 1.44. Okay, here it is 1.44. So if I'm going to divide 1.44 divided by 40.5, then it is coming out to be 0.035 into 10 raised to the power 4.
Yes, sir.
Okay, let me check it only. Cross check the value. Okay, tell me the value of NH3. That is 1.2 into 10 raised to the power minus 2 raised to the power 2, right? Is this right?
Yes, sir.
Then 1.5 into 10 raised to the power minus 2 raised to the power 1, and 3 into 10 raised to the power minus 2 raised to the power 3. So it will be almost 3 into 2, that is raised to the power 6 minus 6, or minus 2, that will be 8. It will come out to be this much. Okay, just check it out. Maybe it is this is the right answer. Okay, everyone, you will check it out. Okay, Krishna,
Yes, sir.
just check it out. Okay, and I'm going to give you another question, then I'll check it. Just write a question. At equilibrium, calculation mistake there will be, the concentrations of N2 equals to 3 into 10 raised to the power minus 3m, and O2, here it is O2 given, and O2 equals to 4.2 into 10 raised to the power minus 3m, and NO equals to 2.8 into 10 raised to the power minus 3m in a sealed vessel at 800 Kelvin. What will be Kc for? What will be the Kc for reaction? Reaction is given as N2 gaseous state plus O2 gaseous state will give 2NO gaseous state. Okay, I'm going to check the previous question. Just write it and let me know if you are done with this.
Done, sir.
Okay, what is your answer?
No, sir. I wrote the question.
Okay, then try it. Let me know if you are done with this. Very good, everyone. Okay, wait a minute. So just correct it. The answer will come out to be this. I just wrote the answer from the book, and check it on your own too. Okay, Reshna, is
Yes, sir.
everyone okay with this?
Yes, sir.
Okay.
Yes, sir.
So if I will say, going for the this is the right answer. You told me to like this. KC is this, right?
Yes, sir.
Okay, moving to the next topic. Unit of KP and KC. Unit of KP and KC. So basically KC and KP depends upon the reaction, because if you will find out, if you are going to find out, just let me know. PCl5 gaseous state will give PCl3 gaseous state plus Cl2. And if I will say what is the unit of Kc, so if I'm going to take, if I'm I just remember this is the reaction, and what is the formula? Formula will be like PCl3 and like Cl2, and here it will be PCl5, right? Unit of Kc. So whatever is the unit of this quantity, it will be equal to the unit of Kc, right?
Yes, sir.
So what is the unit of PCl3? This is mole per liter. Also, what is the unit of Cl2? This is also mole per liter. Upon what is the unit of this? So this is also mole per liter. And you will see, and you can easily see that, this will be cancelled. This will be cancelled, and it will be mole per liter, right? Unit of Kc is mole per liter. But if I'm going to give you an example, like another example, and this is the required equation, and if you are going to write the value of Kc is like H2 I2 upon Hi to the power 2, right, everyone?
Yes, sir.
Yes.
Yes, sir.
Now what is the unit of this? Mole per liter. What is the unit of this? Mole per liter. Mole per liter. And what is the unit of this? Mole per liter to the power 2. So can I cancel both with this?
Yes.
Yes,
Yes.
sir.
And here it will be unitless. You can see it is unitless. So what I want to say is that the unit of Kc is changing according to the reaction. Everyone, right?
Yes, sir.
Correct?
Yes,
So
sir.
what will be the unit of Kc? And again, in the same way, the Kc unit of Kc is working, the unit of Kp will also vary. In the same way the unit of Kc is varying, the unit of Kp will also be varying. So how will we find the unit of Kc? So here is the solution of your problem. Unit of Kc will be equal to mole per liter raised to the power delta n. You know that in terms of Kc, we take aqueous as well as gaseous state, right? So we can easily calculate the value of delta n like we did in thermodynamics. Krishna, Ifra,
Yes, sir.
Muhammad.
Yes, sir.
And
Yes,
the
sir.
unit of Kp will be atm or bar, whatever it is, to the power delta n. Delta Ng, because it is especially for gas, so we will just consider gas. And we know that delta n is equal to number of moles of product minus number of moles of reactant. And here delta Ng is equal to number of moles of product in gaseous state minus number of moles of reactant in gaseous state. Is that clear, everyone?
Yes, sir.
So
Yes, sir.
whenever there is a question of unit and the reaction is given, So you can easily apply this instead of writing the expression Kc for Kc, and instead the writing the expression for Kp and then calculate it, you can easily get it by this. Is that clear?
Yes, sir.
Just
Yes.
just for checking, just take this example. We just took it as PCl5 will give PCl3 plus Cl2. Just we know it's all in gaseous state, so delta N has a value 1, because number of moles of product is 2, number of moles of reactant is 1, right?
Yes, sir.
So applying this formula for this reaction, the value of mole per liter will be 1. And just check it in the previous question, what is the unit of this? Mole per liter, same.
Yes, sir.
And I am going to check it for this delta N. Delta N has a value, delta N has a value 0, right? So
Yes.
Kc has a unit mole per liter to the power 0, and it will be 1. That is unitless number. Is that clear, Krishna, Efra, Saif?
Yes, sir.
Yes, sir.
So first write this, and then we will go to that.
Done, sir.
Everyone done?
1 minute, sir.
Okay, take your time.
Done, sir.
Done. Everyone done?
Yes, sir. Sir, can you scroll a bit down?
Yes, yes, why not? Is it okay?
Yes, sir.
So when will be your final exams?
Sir, around between of March or end of March, sir.
Okay, what about you, Ifra and Saif?
Sir, term 2.
Yes, the final one.
Sir, same time March
For me
or end
also,
of.
sir.
Okay, okay. Are you done with this, Saif?
Yes, sir.
Okay. So here we just learn about Kp and Kc, and we are going to find out basically relationship between Kp and Kc. A relationship between Kp and Kc. So I'm going to write a equation which I already wrote in the previous slide. AA plus BB will give CC plus DD, right? And if I'm going to write Kc for this reaction, you will see C raised to the power C, D raised to the power D upon A raised to the power A and B raised to the power B. What does this C, capital C, D, A, B represents? It represents the molarity of C, molarity of D, molarity of A, molarity of B, right?
Yes, sir.
Okay, very good. Now, going to write Kp for the same reaction. So, Kp will be like Pc raised to the power C, Pd raised to the power D, Pa raised to the power A, Pb raised to the power B, right? Everyone?
Yes, sir.
Yes, sir.
So, you already know that the ideal gas equation, you know that PV is equal to nRT. Everyone knows that.
Yes.
Now I'm going to apply, since always remember that I forgot, this reversible reaction is carried out in open vessel or closed vessel?
Open vessel.
Open vessel. Ifra?
So can you repeat your question? Reverse.
Reversible process or reversible reaction is carried out in open vessel or closed vessel? Saif, you can also answer me. Reversible process is carried out in open vessel or closed vessel? Ifra, am I audible? So I'm going to say, Krishna, am I audible?
Yes, sir.
Just
Sir, I
see.
think it's closed vessel only, sir.
Yes, yes, exactly. N2 in gaseous state, 3s2 in gaseous state. This is the reactant. If it is open, then it will go to the surrounding or not.
Yes, sir.
And NH3 which also in gaseous state, so it will be out from this vessel. So it is always considered, it is always carried out in
Closed vessel.
closed vessel. Carried out in closed vessel. Is that clear, Saf?
Yes, sir.
So please speak up whenever I ask question 2. Okay. So PV is equal to nRT. Just think about it. If I'm going to apply partial pressure of A, okay, let me know if I'm asking you something. What I want to ask is that what is the volume if this A, B, C, and D, this A, B, C, and D is present in this vessel, and the volume of vessel is V. So my question is that what is the volume of A, what is the volume of B, what is the volume of C, what is the volume of D?
So volume of all four is V.
V. Very good. That means the volume of all gases are same as that of the volume of container or vessel. Is that clear, Krishna, Saif?
Yes, sir.
Yes, sir.
So I'm going to write V is equal to N by V into RT. Can I write it like this?
Yes,
Yes,
sir.
sir.
Now
Yes, sir.
you will see that this is number of moles, this is volume. That means we can say moles per liter. Moles per liter, that represents molarity. That represents molarity or not?
Yes, sir.
Number of moles per unit
Yes.
volume of solution. So basically this C is for concentration, this C is for concentration, or I can write M also. If you want to write M, you can write it. Okay, so I'm going to apply for each and every gases. I am writing here PA, so it will be concentration of A into R into T. Can I write it?
Yes.
In
Yes,
the
sir.
same way, if I'm writing PB, that means CB into RT. So for gas C, PC, so it will be CC RT. And for gas D, I'm going to write PD, so it will be CDRT. Is that clear, everyone?
Yes, sir.
So
Yes, sir.
here is the PC. This is partial pressure of C, partial pressure of D, partial pressure of A, partial pressure of B. And the value of partial pressure of A, partial pressure of B, partial pressure of C, partial pressure of D. So can I put CART in the place of PC? Sorry, in the place of PA?
Yes.
Yes, sir.
So
Yes.
what I want to say is that I'm going to replace PC from this, okay, PD from this, sorry, PD from this. So you are going to see a change in the equation, that is Kp will be equal to, here what it was, PC. So what is the value of PC? CCRT raised to the power, tell me, C, and here it will be the result is very important, not the derivation, again I am saying. And here it was CART raised to the power A and CBRT raised to the power B. Is that correct? I just replaced the value. Is that okay
Yes, sir.
with you, everyone? Now see, what is this? What is this CC? CC represents molarity of C, right?
Yes, sir.
Molarity of C. So molarity of C, concentration of C. In the previous question, we just took molarity of C is C. Wait. You can see molarity of C is, concentration of C is C, D is D, and A is A, B is B, B raised to the power B. I forgot to write. Now, can I replace molarity of CC as C, RT raised to the power C, because, and CD, this is the molarity of D. Can I replace it or not? Tell me.
Yes, sir.
Krishna,
Sir, can you say what you just did?
explain again, sir? I didn't get it.
explain. Very good, no problem. You can see for this reaction, I'm talking about for this reaction, right? For this reaction.
Yes.
So for this reaction, you are going to see Kc is C raised to the power C. That means concentration of C is C,
Yes, sir.
concentration of D is D, and here what we wrote, Cc means concentration of C, Cd means concentration of D, concentration of Ca,
Yes, sir.
right? So can
Yes.
I replace Ca as C, Cd as D, Cb as B, Ca as A? Can I replace it or not?
Yes, sir.
Because in the expression of Kc, we took concentration of C as C, D as D, B as B, A as A, or for the relation between Kp and Kc, we need to have something in common. Saif, Krishna, Ifra.
Yes, sir.
Yes, sir.
Okay, thank you. Now see, what I'm going to do is Kp is this. Now Kp is, can I write it like this, C raised to the power C, D raised to the power D? What I just did is just RT raised to the power C plus D. It's maths. C raised to the power C, R raised to the power C, T raised to the power C, and D raised to the power D, R raised to the power D, T raised to the power D. So you can see RT same. So I just took it as common. And is it okay to write direct this, or I should explain it in one or two more steps?
No, sir. Understood.
Yes,
Saif, are you comfortable?
Yes, sir.
Okay, thank you. Now just I took this and this outside, A raised to the power A, B raised to the power B, and here it will be RT raised to the power A plus B, right? And if you are going to see the constant expression for this part, Kc, C raised to the power C, D raised to the power D, what it is equal to? It is equal to Kc. So can I do the same to this part? Can I write it at this place? Can I write it Kc?
yes, sir.
Yes, sir.
Yes,
Sep,
sir.
and here it will be RT raised to the power exponent, the method of exponent, C plus D minus A plus B. Can I
Yes,
write
sir.
it?
Yes, sir.
And if you are going to see, you will find out that This C plus D is basically number of moles of product minus number of moles of reactant. That represents delta N.
Yes, sir.
Tell me, that represents delta N or not?
Yes, sir.
Yes, sir.
Yes, sir.
So here is a relation between Kp and Kc. Kp is equal to Kc RT raised to the power delta Ng, and delta Ng represents number of moles of product in gaseous state, number of moles of reactant in gaseous state. Simple. Is this clear, everyone?
Yes, sir.
Yes, sir.
Okay, then write it. The relationship between Kp and Kc. If you are done with this, let me know.
Done, sir.
Done, everyone?
Just a minute, sir. Done, sir.
Done, everyone.
One
What
minute.
about okay, okay. Take your time, no problem. Safe.
Yes, done.
Done. Very good. You have to do this also. If you are done with this, oh, sorry. If you are done with this, let me know.
Done, sir.
Very good, Seth. What about you?
Yes, sir.
Very good. Do it, and further we'll study in the next class. Okay. Done.
Done, sir.
Okay, thank you. Seth, if you are done,
No,
let
no,
me-
1 minute.
Okay, okay. Take your time.
Thank you, sir.
Okay, thank you. You may go, Krishna. Sorry, sorry.